For this problem on the topic of projectile motion, we are told that a boy with a water balloon slingshot and the ground level fires the water balloon towards his friend in a tree, which has a height of h, and the tree is a distance d away, and we want to show that by letting go of the tree, the boy in the tree makes the wrong move. Now we'll choose the origin to be the location from which the balloon is fired, and we'll choose the upward direction to be the positive y direction. Assume that the boy in the tree is a distance h up from the point at which the balloon is fired, and that the tree is a horizontal distance d from the point at which the balloon is fired. The equations of motion for the balloon and boy are as follows, using constant acceleration relationships. So the horizontal range for the balloon is equal to v naught cosine theta naught times t, and the vertical displacement of the balloon is given as its initial position 0 plus v naught times the sine of theta naught times t minus a half g t squared. The vertical position of the boy as he leaps from the tree is equal to his original height h minus a half g t squared. Now we'll use the horizontal motion at constant velocity to find the elapsed time after the balloon has traveled the distance d to the right. Now we know d is equal to v naught times the cosine of theta naught times t, which means that the time t is equal to d over v naught cosine theta naught. So where will the balloon be vertically at this time? So the y displacement of the balloon is equal to v naught sine theta naught times t minus a half g t squared, which is v naught sine theta naught times the expression for t, which is d over v naught cosine theta naught minus a half g times, again, the expression for t is d over v naught cosine theta naught squared. So if we simplify this expression, this becomes d tan theta naught minus a half g into d over v naught cosine theta naught squared. Now we need to find where the boy will be vertically at this time. So the boy's vertical position, y boy, is equal to h minus a half g t squared, which is equal to h minus a half g, and the expression for time again is d over v naught cosine theta naught squared, and h we can see is d tan theta naught. So this is d tan theta naught minus a half g into d over v naught cosine theta naught squared. And we can see from here that the vertical position of the balloon is equal at that time to the vertical position of the boy. And so the boy and the balloon are at the same height, at the same horizontal location, at the same time, which means they will collide.